Okay, hello, bonsoir. Thanks for being here. So for this 22nd session of Paris Videotech. So tonight we'll talk about a lot of different acronyms, as you can see. So 5G, CadVise, of course PVT, because you are at Paris Videotech. But what's new? So for us, if you are at IBC, last weekend, so we organized a meta meetup with Barcelona Videotech, London Videotech, Madrid Videotech, and us, of course. So it was very nice to meet everyone at IBC and have the possibility to share a drink with all the people. And as always, so we are saying the same thing at each event, but we are looking for talks and sponsors. So if you want to support the association, don't hesitate to contact us at this email address. So contact@parisvideotech.com. And we can organize this event thanks to Orange, who is the main sponsor for this event. So I will let them come to the stage and talk about the new product, or the new CDN. So thanks a lot, Orange.
Ouais. On passe les slides comme ça. D'accord, ok. Là, c'est bon? Non. Ça marche pas? C'est pas moi, hein? Wasn't me. Fuck. Anyway, I can do without the slides, no, the problem. Oh, magique! Ouais, ok, pour pas shooter dans le câble. Ouais. Vas-y, ok. Merci. First of all, I just wanted to tell you that we are at Orange extremely delighted to support this event. Sorry. So that's the first thing. And I wanted to, and thank you, Simon, to give us 5 to 10 minutes to explain and to speak about our new offer. We had the chance to introduce last week during the IBC. So our offer is called now Content Delivery Boost. But just for kind of information for the guys who don't know Orange Group, this is one of the, 12 or 11 tier 1 in the world. I think we've got something like 250 million of subscribers across the world, mobile, fibers, and DSL in particular. So that's something. We've got something, and this is one of the particularities in the telcos. We love to speak about fibers. We've got something like 400,000 kilometers of submarine cable across the world. So that's huge, as you can imagine. And that's it for the introduction of Orange. So what we just introduced during the IBC is the new concept we just launched, Actually, it was in June. This is a smart combination between, of course, the granular, extremely granular IP network we have across the world, and we spoke earlier, in particular in some regions, some areas. And of course, we have deployed some new very high-performing servers. This is some Dell servers. I think they've got something like 150 gigabytes per second, but we can go up very fast. And flexible software with advanced feature provided by our partner G-Core. This is the new platform. And in terms of positioning, this is absolutely, different compared to our competitors. I can see in the room, by the way. And some others. So that means that we are probably the only trusted CDN in Europe, Middle East, and Africa. Trusted CDN means some criteria. I will explain if I've got some time a little bit later on. And we've got another specific positioning, which is, I would say, kind of geographical one, because we are extremely present in Africa, Middle East in particular. Well, this is extreme marketing, as Simon said, so I will go very fast on that. But one of the others, the other particularity, specificity of our new offer is that because we own our network, we can manage end-to-end solution, and I would say this is secure by design. And of course, this is another one. We are not just selling CDN or edge or cloud, but we have a full vision of all the ecosystem. Well, this is a little more technical, but just to explain that we are a little bit more above industry standard or expectation. I will give you the slide later and we will see that. And of course, our concept, just if you have got, again, 5 minutes about that, the trusted CDN. Why trusted CDN? And again, sorry, but we are probably the only player right now to be European-based and French-based in particular, which allow us to be recognized and known as, strictly under the UE regulation. That means this is a kind of specificity. Most of our competitors are for China, India, or US-based, and we are European. And we are happy to say that we can work in full trust with a lot of public, parapublic, government sector, in particular in Europe, Middle East, and Africa. I spoke about Africa because this is another specificity of Orange CDN, Content Delivery Boost. We are present in more than 10, 12 countries in the continent, including Middle East. We are in 15, and we have deployed 38 POPs in this region, in those regions, coming from, of course, as I said, this is really part of Orange DNA. We are present in Africa since the beginning. And this is why, first of all, this is because we can see globally that the traffic is growing very fast in Africa. And fortunately, we are present for a very long time. Our competitors are not there yet. In terms of performance, what you can see, this is a CDN perf. Sorry? Oh, fuck. Sorry. I'm not looking. I didn't touch anything, right? Okay, anyway, I will go. Not lucky, right? Thank you. I just wanted to conclude the introduction with, because we announced in particular at the IBC that we have a new partnership in terms of software, the software layer we explained a little bit earlier today, that allow us not only to have, as we said, a coverage in Europe, Middle East, and Africa, but globally, provided by our partner G-Core. And I think I am. Oh, yeah. Yes. Just if you've got, again, 1 or 2 minutes. Interesting enough, just wanted to explain what we have deployed. Next time, Simon, if you want, I will be able to make a kind of very deep dive technical presentation about the architecture and design. But I just wanted to simplify. We have just deployed in France, as I said, in May, June, as a prototype, the new CDN platform, Edge and CDN platform in France, totally embedded in the AS3215 and the AS OTI 5511, which is the double of international transit, IP transit, sorry. And what you can see, this is all the POPs are extremely strategically located in France, inside the Orange France network. that provide us really, really good performance and, of course, as I said, a high level of security. Thank you.
Thanks a lot, Orange. So now let's go back to the schedule we'll have tonight. So we'll have 3 talks, 2, let's say, big talks and a small one to finish. So let's start with 5G Mag and with Jordi, who will talk about the fostering media connectivity ecosystem. So Jordi.
Perfect, thank you very much. Hello, it's a pleasure to be here. Thanks for the invite. I know Jules was a bit scared at the beginning. I have plenty of slides, but no worries, I'll keep time. So first of all, I would like to start explaining what 5G Mag is. Anybody knows what 5G Mag is? Beyond those participating already. So 5G Mag is an association that was created in 2019. Actually, we were presented during IBC. And let's say the main objective is to foster collaboration between the media and the telecom industries in order to work on global internet, 5G-based access, global APIs, and global technologies in the end for multimedia applications. So as you know, well, typically the media industry have been working with, I would say, dedicated standards, call it, for instance, DVB or others, DAB, and so on. But obviously, we are transiting towards the internet, and there's a feeling sometimes that the internet is basically managed by big tech, and then you need to basically take whatever you are given. There's no option to just do anything else than what, let's say, you are given as configuration options and so on, and that's it. And well, the main objective is to work and engage with the relevant stakeholders in the value chain, with the relevant standardization organizations, and try to shape technology according to the needs for these multimedia applications, both, let's say, more traditional, as could be, let's say, streaming, for instance, but also looking at other applications in the sense of, for instance, extended reality and others. We don't like to do a lot of blah, blah, blah and paperwork, right? So we have established, for instance, our open source reference tools program, where we are developing the standards, we are developing the technology in order to allow the industry to test how it works, and even more to, well, thanks to a quite IPR-friendly, let's say, license to develop products and to develop, let's say, systems that we can push into the market. The association is also promoting the technology uptake or all of what we do, and what we do is, as I said, very pragmatic work. We work on 3 pillars, as you can see. One would be, let's say, pre-standardization, which is more around requirements, industry consensus, which is something important, so that we end up in solutions that, well, based on standards that in the end are global or that have a global footprint. Well, it makes sense that we avoid fragmentation, and that in the end, well, if you use, for instance, network slicing in France, well, you would expect to have the same set of control parameters and the same sort of features also if you deploy the same system somewhere else. We also assess opportunities coming from standards or from the evolution of technology. And then what we do is basically we are not doing standardization, so we are not a standard body. We don't develop our standards, basically because we think it may be easier to influence or to inject requirements into standards made by others, right? And that involves 3GPP, that may involve at some point IETF, that may involve MPEG, right? So it's more to have a framework in which we can interface with other organizations and try to shape these technologies, and it'll have a global footprint, have global ecosystems, and then, well, maybe easier, instead of reinventing stuff or doing our own standards, to try to influence them and get features into them. Another point we do is to work on profiles and guidelines. So these standards, and I'm talking in particular, for instance, 3GPP, if you are familiarized with them, in order to develop your system, you have thousands of pages and thousands of documents to look at, right? So it would be interesting, at least for the industry and at least for even for SMEs, developing small parts of the, let's say, of the media supply chain or the value chain, to have some sort of guidelines to tell you, well, this is interesting, this is how it works, these are the APIs. If you want to develop some software, to develop an application or a service, look, let's say, at these parts of the standards and forget the rest. And then a third pillar that we are covering is more looking at what we call post-standardization. That would be, okay, we know there are many people involved in developing standards, codecs, features, and so on. However, how to end up in fostering the ecosystem so that these features and these technologies end up into the market, right? Because you don't want, let's say, your APR in the standard. You would like these standards or these technologies to end up in products in the market, and in the end also to provide some benefits in terms of efficiencies, automation, better workflows, and so on. So we have established our own software development program that I will talk briefly in a bit. And the idea is to develop tools in order to validate the standards, in order to validate technology, and then move it into trials, demos, show telecom operators how the features developed work, show service providers how they work, show app developers what are the APIs and what they need to do in order to develop applications, and in the end, well, foster the ecosystem of, let's say, multimedia applications linked to connectivity. We started with just a few areas of work and topics. However, well, things are evolving, and as more members are joining, well, the interest, let's say, or the amount of topics is diversifying. Today, I think I will concentrate mostly on media over IP for live contribution and remote production. So this is more or less all what has to do with uplink streaming and more kind of local area network or wireless local area network traffic management. I'll also deal a little bit with 5G media streaming as well, right? But we have other topics like 5G broadcast, 5G multicast broadcast, what we call media beyond 2D, which is more on volumetric video, multi-view, and more recently we also have started a line of work on extended reality and immersive media. So going into a little bit more details, for instance, when it comes to media over IP, and as I said, we are looking at live contribution and remote production, right? But going, I would say, beyond what you see today, right? So what you see today is basically we take cellular bonding unit. There are some known companies. You replace some modems, right? So you get today an LTE SIM card and an LTE modem. You replace this SIM card and modem by a 5G one, and suddenly you can do like press releases, awards, trials, and so on. But what have you really taken from the 5G standards of work? What have you really leveraged from the 5G standards? Well, very little, right? So you are treating the 5G network as a bit pipe, let's say, as a best effort and managed network, and that's not what, let's say, 5G was meant or is meant to be, right? So there are opportunities here to have, to make use of the, let's say, telecom network or a private network in a more, let's say, intelligent way in order to manage media, manage video, and get some benefits. We are also dealing with local area networks in venues, or what could be an ad hoc setup, right? So it's not just about transporting video in the uplink, it's more about, well, I can have some connectivity here. Can I develop my local area network, and can I leverage, let's say, this network that is running here in a way that, well, I can have guaranteed quality of service, I can request some sort of network assistance, I can predict throughput, I can leverage, for instance, PTP, coming from this network without having to bring my grandmaster attached to it. Can I leverage edge computing capabilities, right? So we are also dealing with these setups. And we are also analyzing the status of the market in terms of ecosystem, in terms of devices, the regulatory framework, what happens if you use a network slice from an operator, how does it work, what are the APIs, what I am actually able to configure, or, well, in case of a private network, what was the status of the spectrum, what's the availability, how to set up my private network if I do it alone or I do it in collaboration with a telco. There's plenty of information on the website. I won't go into details. However, I would like to highlight a new work item that we launched that is looking actually at these features that go beyond the typical, let's say, throughput and latency and so on, and a little bit, let's say, the hype, right? They go more into opportunities for automation, for enhancing a little bit the workflows. Device onboarding and provisioning is a topic. Actually, we've recently published a report. We are looking at time-sensitive communications in these wireless local area networks. We are looking at interworking between 3GPP and non-3GPP access. Call it Wi-Fi or call it, let's say, a non-new radio access technology. We have a big piece of work about to start on uplink media streaming. That would be, for instance, getting details from the network in order to act on the way video is encoded, quality of service, priority in the local area network, and so on. And well, we want to also. If you are interested in any of this work, your man, I think it's Thibaut, who is actually the chair of our content production group. On the website, you have some reports that we've done. And as I said, the idea was to look beyond just, let's say, connectivity, or beyond just, let's say, taking cellular bonding and replacing some SIM cards and that's it, right? The idea was to look into more details in terms of architectures and how to leverage different features. We've done also some work on 5G non-public networks. That would be all what involves setting up your 5G network, let's say for private use as a kind of hotspot, or in connection with a public network, which would be, let's say, dealing with network slicing. And we have developed, let's say, some concepts and ideas around the scenarios. One important piece of work we've also done, well, our members have done, is to contribute to a 3GPP work item on media production over 5G MPN systems. And here I have highlighted this idea of managing or dynamically mapping and dynamically managing quality of service between different sources, for instance, different cameras, that are arriving to a mixer, right? So obviously in a wireless system, you have the constraint that there is no infinite capacity. However, it would be beneficial if you could get some insight of the network status, for instance, if you could turn off some of the cameras or put some of the cameras into a very low bitrate mode that would allow you, from a, let's say, program director point of view, to still know what the cameras are transmitting, but do not load the network, right? If you go to a private network, normally what you are given is 100 megahertz, and if you take into account that this TDD and so on, I mean, the capacity is not great, right? So it would be good to use this spectrum more efficiently, and also from a telco point of view, to use spectrum more efficiency, be able to offer, let's say, more capacity even to different customers, right? Not that a very inefficient workflow is, let's say, saturating or consuming a lot of capacity that otherwise you could transfer into other, let's say, into other setups or into other customers. So we are looking at this. There is some insight in this technical report. but we want to leverage it and do some more work in order to understand, as I said, APIs, what is actually able to be configured, and so on. We've done also some work on a Spectrum, actually, to inform our members on what are the different possibilities. If you see these 5G, these private 5G networks, how they are being, let's say, what is the framework to deploy them? There's a little bit of, I would say, fragmentation in the approach between different regulators in Europe. Well, the idea here was to actually have a look at all the methods that have been developed around the world, and perhaps question a little bit if, let's say, assigning a spectrum for, let's say, 10 years let's say, to a very specific location where, well, the moment you are outside this location, you cannot use this spectrum anywhere else. Well, if that's the best use of a spectrum for some of the media applications, that would need, let's say, a more instantaneous and a more ad hoc based request for a spectrum in order to deploy these private networks. So there's some insights here, but as I said, just to discuss and to present the different alternatives. Finally, as I mentioned, and I go with some examples, so just to show a little bit that 5G is not just, as I said, connectivity, latency, and blah, blah, blah. There's some concepts here coming directly from the specs. One is the credential holder. For instance, imagine you come to a venue with your equipment, and you won't expect, let's say, that you need to arrive before, that you need to provide the venue owner with the credentials or with the data of the SIM cards that you are putting in your cameras and so on, and then they need to load them into a database. And well, the idea here, for instance, is that you go with your SIM card and you tell the network operator of the venue, please, there is a server in my premises that I want to consult in order to register my equipment, right? And just with let's say, with a connection, you are able to arrive somewhere, to put your camera, then the camera will register against the server that you have at home, right? No need to put anything on the venue or in the telco network, and it works, right? So these are things that nobody seems to be thinking about, but they exist, right? So we need to raise awareness. And the other thing is about provisioning, right? So for instance, I'd like to work with a telecom operator, and I would like to bring my equipment, my cameras, connect them to a telco network, obtain the configuration of network slicing, for instance, but automatically. I don't expect to communicate a lot beforehand and let's say, to decrease all this complexity. Also, I would like just to go there, and actually my SIM cards that are empty, or even an eSIM, they can be loaded with all the necessary parameters from a provisioning server that is installed in the network. So these are the type of things that we are looking at and that we want to develop further. Another area of work, and we go more to the distribution domain, is about media streaming, right? And here is, again, is a little bit moving beyond OTT, but why? Well, because the 5G standards offer opportunities for collaborating with telecom operators in order to leverage some of the features coming with 5G, dynamic quality of service policies, metrics from the network that can be obtained by the service provider, metrics from the, let's say, quality of experience from the users, consumption, metrics on consumption of a specific, let's say, video, TV program, or whatever, that can be reported by the client, by the network, towards the service provider. So we are working on these concepts, on well, what are the APIs and so on. And actually, as I said, the idea here was, and it started from 3GPP into something called 5G media streaming, that it's active in SA4 actually, to, well, how can, let's say, multimedia applications and mobile networks collaborate in order to do something else than just, let's say, OTT. And this is aligned with the exposure of functionalities, APIs, and so on from the mobile industry. Just, if you see the screen, this is the typical 5G system, right? If you would have content coming from a CDN, you would just put it on the UPF, and that's basically OTT, right? So there is nothing, let's say, different that is done by the 5G network to this content. However, in the 5G core, there are some functionalities like the PCF, the policy control function, that enables to attach an application function to configure things, right? And to start using the 5G network in a more intelligent way. Also for content delivery, also for, let's say, content coming from a CDN. CDN that can be external or that can be, let's say, a telco CDN, right? And this is where 5G media streaming architecture came, right? And that's what we are working on, right? In order to, well, beyond just content hosting, to also well, make use of some features like network assistance for throughput estimation, background data transfer, delivery boost. That would be, well, I can predict that soon there won't be coverage. Let's modify a little bit the length of our buffers. Let's ask the network to increase the data rate spontaneously, and let's try to leverage a little bit this boost in order to prevent that we are, let's say, out of coverage, or that we are pausing the video for a long time. There are opportunities also to track well, the different representations, right, and dynamically change representations during a streaming session according to the quality of the network. We can report the quality of experience from users, and we can report as well the consumption. We are actually trying to harmonize this with the CDN world on, for instance, CMCD, CMSD, and the way all this data is collected. I would just leave this for more details, because on the website there is much more information. We are also dealing with 5G broadcast. That would be basically to have a global standards based on 3GPP technologies for those that would like, let's say, to do broadcast, and that involves, well, TV, radio, emergency alerts. You could see, like, I don't know, DVB or DAB. Well, it's impossible to have them in a phone, that's clear. Well, perhaps if this standard is based, let's say, on a 3GPP technology, there may be more chances than having to add, let's say, extra silicon or an extra chipset into a smartphone. So we have a lot of work also from our members done in this area. I just leave, let's say, some links in the presentation that can be forwarded afterwards. But basically, the idea is to integrate broadcast capabilities within the OTT chain, right? So it's not about, well, creating a parallel platform. It's actually that if I am using my phone and I am connecting to a live stream from an OTT app of my service provider, well, if this content is delivered on broadcast, the middleware can, let's say, receive the Dash HLS segments over broadcast, and this is seamless to the user, right? So you just install an app, and if it happens that the content is linear or live, well, it can come on broadcast. And if not, well, it's unicast. It exists today, and you can watch TV and listen to radio on your phone already. There's also some work on provisioning emergency alerts on the same basis, right, on broadcast. Another, let's say, topic that we are dealing with is multicast and broadcast delivery in 5G networks. So this is not about creating a parallel broadcast network. This is about scaling content, scaling live media services within the 5G network. So if many of you imagine there is a football match, we are here, and then we get connected all to the same live stream, all in the same cell, or let's say in the neighborhood. Well, how to allow this traffic to scale via multicast, right? And then also, well, try to align it as much as possible to unicast in order to, well, to decrease the complexity of the phone and to leverage most of the systems that exist and that increase reliability for unicast. So we have some explainers here that you can consult. Another topic is advanced media services, and as I said, well, this is a quite new topic that we are working on right now, and this is all about beyond just 2 dimensions, right? So we have been spoken about TV and radio, which is more like 2D, right? Call it 2D audio, 2D TV. Well, this is about well, interactive video services, multi-view experiences, volumetric videos, free viewpoint, and so on. And what we are doing is basically to understand what are the different architectures coming from the standards that are applicable, and well, the architectures and the features. And more recently, and this is really, really new, I don't have a lot of material, we are launching a topic on XR and immersive media, and some of our tools, well, there is a Unity player, I think there are 5 GitHub repositories. We are actually asking developers to make some testing on the tools that have been provided. More information on the website. And finally, I would like to present our reference tools, which is the development program. So we said, okay, we can talk a lot about all these applications, we can write papers, we can do a lot of talking, let's say, but that's not enough. It would be interesting actually to implement and to put these technologies closer to developers and closer to the community. So we created a development program. Actually, well, it's quite successful because we have I think 30 repositories in GitHub with plenty of the code that implements most of the things that I have been speaking about. And well, this is totally open, so you don't even need to be a FiGMAC member to participate in the development community. And well, I know there are hundreds of people already in our Slack and in the Google group and so on. So keep an eye on it if you are interested, let's say, in development. And let's say developing applications, playing with APIs, playing with streaming, and so on. There is information here on how to join. All it's in our website. We have our GitHub, as I said. We have a growing community with some companies that are actually contributing software, right? So this is not just let's say project. This is about people contributing, testing, and validating specs. Basically, we are implementing 5G media streaming, and as I said, this is basically what we have implemented. So we have application server, application function. You can play with it. You can attach it even to a commercial 5G network, to a commercial core. We have streaming clients based on Android, based on ExoPlayer, a few functions like the metrics reporting, it's coming, a few more things. There is a table here with the work in progress and what will come next. Have a look, it's all on our website. And we've been successfully presenting all of this actually recently in IBC just a few days ago with the world first public demo of 5G media streaming, basically because nobody else have implemented this, so we were the first one doing the work of implementing it. Repositories are in GitHub, we have releases, and so on. We have some work also on multimedia content delivery. Part of our work is also multicast and broadcast. Then we have our own library of Flute. We have a library of Route as well. There are more things coming. There are releases. For 5G broadcast, we've also implemented some of these repositories, so you can actually build an end-to-end system, even using smartphones. All the information is on our website. We are implementing now the emergency alerts also for 5G broadcast. There was a demo even with pre-commercial devices provided by Qualcomm in the IBC, in our booth. And next steps are on multicast broadcast services. So we want to do this on the telecom network, right? So to use a multicast broadcast as a service of the 5G network. And we have started implemented some of the functions in order to, let's say, encapsulate multicast traffic into the 5G network. And as I said, have a look at our GitHub. There are more things coming, immersive media, XR. I think there's also a repository in artificial intelligence machine learning from 3GPP. So stay tuned and contact us at any time. Thank you.
Thank you. So for now, it's time for question. So we have some microphone here.
Hey, Jordi. You talked about Android, but how does Apple and the iPhones fit into all of this?
So I think we have started with Android, particularly for media streaming, because that was the kind of low-hanging fruit in terms of open source, in terms of well, opening the platform to developers. From iOS, we haven't had a lot of contributions, right? So we are playing with HLS. However, we don't yet have an iOS player, kind of like we have with Exoplayer or like we have with Android platforms. So if anybody is interested, we would be happy to work with iOS and HLS as well. But for the time being, it's all Android.
Do you already have the APIs you need from Apple or not?
We haven't investigated, actually.
Okay. Thanks.
Hey, question, is any of that out of the lab in production somewhere, or is it still most of it only in lab and the 5G is only using basic OTT streaming?
For the moment, 5G is using OTT streaming. Basically, there are few cores even that have the PCF function that is the one that would enable you to start doing like more than just OTT. We've been in touch actually during IBC with some core providers, and we want to start, let's say, testing our application function with commercial PCFs. The thing is our tools, in particular the application function, application server for 5G media streaming, they are 3GPP compliant, so the interfaces are totally compliant. You could take them, you could plug them into a 5G core, and they should run. However, we need to see if the commercial cores can, well, have all these boxes with something inside, not just the box, right? So that's what we are waiting to explore in the next months.
Thanks.
Any other questions? No? Okay, thank you.
Thanks.
Okay, so let's move to our second talk. And Andreas will come to talk about CadVise, so the cloud-based ABR testing.
Thank you. Yeah, great. All right, cool. So, bonjour à tous, or I think once it gets dark, you say bonsoir, right? I'm trying. Yeah, in any case, hello from my side. My name is Andy. I'm a software engineer at Bitmovin since 2 years now. And I have the honors of presenting CadVise, our cloud-based ABR testing system today to you. For a bit of context at first, at Bitmovin, we create solutions to encode, play, and analyze video. And the area that we are operating in today is the player, even more specifically, HTTP adaptive streaming players. So adaptive streaming is kind of a very dynamic environment, right? So such a player needs to do many things at once, like parsing manifests, rendering your frames so that you can see them, scheduling ads, dealing with encryption, and also determining which quality you want to display in the player, right? So your client has different conditions, like network conditions, CPU, different stuff that basically shapes what quality you want to display. You always want to choose the best quality for your client's needs. And as religious software engineers, we want to test each of these parts, right? So we want to make sure that everything works basically the way we expect it to work. That's at least the classical definition. So you have a bunch of input parameters and you have an expected output, and you test your software in these different scenarios. However, these classical approaches only account for software correctness, which means that we are not accommodating for performance in here. And that's what we need to do for ABR, because we can define an ABR that works fine on a logical level, but still doesn't do a good job because it chooses a quality level when playing back that's not suitable for the current client's environments, right? So our foremost priority when choosing the quality is to create the best perceived quality for the end user. And the metric for that is the quality of experience, or short, QAE. I have an example here below with two ABRs, or very simple ABRs to be honest. One always chooses the lowest quality that's available for playback, and one always chooses the highest quality that's available for playback. You can cover both of these functions here with unit tests, and they would look fine on a logical level, but still you don't know if this is nice for the end user, right? So from these tests, we don't know if the quality of experience is going to be great. So diving further into quality of experience, in conjunction with HTTP adaptive streaming players, we have a bunch of different factors that are very prominent. The first one being the initial delay. So that's defined as the time elapsed from triggering the play button or expected playback until the actual playback starts. Research has suggested that up to 16 seconds is fine, kind of, for the end user, except if you're dealing with short form content. So like if you're watching a TikTok video that's lasting 10 seconds, you don't want 16 seconds of startup time, right? That would be suboptimal. This is heavily influenced by the startup bitrate that the player chooses. So if you're choosing a quality that's not suitable for the current network conditions, it's going to take a long time for the buffer to fill, and that in turn creates a large initial delay, which negatively affects your quality of experience. Second factor is adaptation. So that's defined as changing the media quality during the playback according to the client situation or available bandwidth for the client. Here, some interesting findings. The direction into which we adapt has a large influence on whether that's perceived positively or negatively. So switching the quality down, of course, is perceived negatively by the client. Switching it up, the user perceives as positive. Also, very frequent switches, like switching up and down all the time, is something that you should avoid because that also disturbs the user experience. And they found out in research that gradual adaptation is perceived better than like very abrupt changes, like changing from a very low to a very high quality or in the other direction disturbs the quality of experience factor. The third one probably doesn't come as a surprise, but stalling is basically the worst thing that you can have in playback. It's defined as interrupting the playback because our buffer is empty, so we need to wait for new data to fill our buffer until we can continue to playback content again. So that's by far the biggest impact on quality of experience. And users usually tolerate one tiny stalling event per session. If you have multiple, they're immediately going to rate the playback session as very, very badly. So kind of the central question of this presentation is, how can we test the player quality of experience performance? Are there any tools, any things out there that we can use, that we can leverage to know if a player is performing good or bad in terms of quality of experience? So the first and probably obvious choice would be subjective testing. That means you take a bunch of humans, you display them different scenarios, and then you look how they react to these scenarios. So in our concrete example, that means we set the user in front of a computer screen, show them the same video with two ABRs, and let them rate which one they liked better. For that, of course, you need a lab environment. We want to create equal circumstances for all of them, and a pool of test persons that watch your video and judge it. How you would judge that is on a scale from 1 to 5, where 1 is the worst mark that you can give. That basically means playback was super bad, I wasn't able to enjoy it at all, and 5 is the best one, excellent quality of experience. Basically, that's your perfect playback session. In reality, seldomly you can achieve that, to be honest. What you then do, after you collected all these individual responses from the users in terms of your scenarios, is you build an average over them. And that average is defined as the mean opinion score that you get for a certain scenario. The bright side of this is that it's from a scientific perspective, most accurate way to get the quality of experience or MOS score. Because there's nothing closer to the actual truth than asking human beings, like, how did you like that playback session, right? The downside, however, is very resource intensive, like a lot of time, money, and effort goes into setting up such experiments. If we think about today's agile software development world, where we have releases on a weekly basis or bi-weekly basis, setting up such an experience once a week would be quite a tremendous effort, right? So that's not a fit for our case. We need to look further and maybe step into objective testing, which means we are trying to find algorithms that can predict the quality of experience as close as possible to the actual results. That's, I would say, a classic machine learning job, right? You have a huge database of subjective experiment results, and you're trying to find an algorithm that kind of fits the results that you have in the database there, so that you can predict in future what the perceived quality of experience is going to be for a certain user. Fortunately for us, the ITU released a recommendation already under the number P1203. I'm not going to read this immensely long name, but you can Google it if you're interested. What I do tell you is that there is a reference implementation for this recommendation available in Python, which is basically a tool that you can use to evaluate your quality of experience. You feed that Python script some playback session data, gonna hop into the details later in the presentation. And what it tells you is the mean opinion score for your playback session. What would a user have rated this playback if they would have watched it? This is backed by some scientific papers that tell you how the model was trained and everything. I have the citations inside there in case you're interested. That already sounds a lot more feasible than collecting people every week and doing tedious manual testing, right? But we're still missing some parts that we need for it to be really operative. First one is we need a test page or test setup for our player, right? We need to collect the data from the player that's relevant, so stalls, quality switches, which qualities were played back. We need to transform that data for the Python script to be in the right format, and we also need to simulate network conditions, right? Because we want to create certain scenarios that are reproducible for our testing setup. We want to check how does the player perform if the network bandwidth is really low? How does it perform if it fluctuates all the time? These are different things we want to consider. So basically, all of these requirements literally scream CadVise. In case you're wondering what it means, now it's the resolution. It means cloud-based adaptive video stream evaluation. And it's a scientific paper that was released by the University of Klagenfurt in 2020, like 3 years ago. It's also available as an open source implementation. So I linked the repo here. If you want to try it out yourself at the end of the presentation or want to have a look, you can just peek into the code a bit. What it is a test bed for adaptive bitrate experiments, which means you can determine the quality of experience with the player you choose, different players supported, in a certain network scenario, okay? And you don't need any on-premise resources for that because it's all cloud-based. So what does it look like? I had some animations in there, but I'm just gonna use the pointer to show you. It all starts with a curious video dev who has a player that they want to test and see how does it perform in certain scenarios. They then invoke this CadVise tool, which is basically a script in its original form, and tell, okay, I want to use this player with this version and this network profile, and check what it's doing, what the quality of experience for it is. The system then asks a cloud provider, it could be any cloud computing provider. In this example, we used AWS. That's also what was used in the paper. And spins up two EC2 instances, two cloud computing instances in that case. One acts as the client who plays back the video and basically conducts the playback session. And the second one is a content server. So you have some static asset onto there, and the client is communicating with the content server to play back your asset, downloading the manifest, downloading all the segments and stuff. Between these two instances, we have network shaping in place. So we can manipulate and restrict the available bandwidth and latency for these so that we can simulate certain network scenarios just as we wanted before. To actually deploy onto these instances, so for them to fulfill their role, we're deploying some Docker containers that then contain the player or the web server. During this whole playback session, both of these instances, so the client and the server, report their data into a log database. There we have everything inside regarding stalls, quality switches, and segment qualities that we want to record. We then need this log data to feed it into the algorithm, the Python script basically that I showed before, and then a mean opinion score is generated. So that's how we get around needing actual people every week to conduct our QA experiments. You can use this result data then to analyze or visualize or do cool stuff with it and know actually how your player is performing. So zooming into the parts of that a bit, first, I already teased it. At its core, it's a bash script that you invoke that coordinates this whole process, like parsing the input, requesting the startup of these cloud instances, priming them. You can imagine there's a lot of dependencies and stuff going on under the hood that you need. And also then triggering the experiment start. Such an experiment start means first starting the playback on the client side, and secondly activating the bandwidth shaping between the two so that we have our controlled network environment there. Then waits for the experiment to finish and cleans up all the resources that we created afterwards. So that's the role of that script. I have a sample invocation down there. So simple shell script invocation. We have a players parameter where we say, well, which players do we want? We can give the experiment a title. We can choose a network scenario. And here we just have some authentication stuff for AWS in that sense. Then the client instance is probably doing most of the heavy lifting in this setup. It's basically a page that runs the web-based HTTP adaptive streaming player. Of course, if you have like an iOS device that runs it in an app, you need a kind of a different setup, but this one is tailored among web-based players. So we have literally a Chrome browser launched in full screen, running that player with the playback session for the specified amount of time. And while it's playing back the video, it reports back important data to this log database, like the stalls, where did they occur in the video and how long did they take, quality switches, between which qualities did we change and how often, and which segments were downloaded in that whole process. Out of the box, 3 players are supported, the Bitmovin player, Dash.js, and the Shaka player, but you can really use any web-based player as long as you just put it into a web page and deploy it to that script. All of that is debuggable with VNC. I think that's a GIF, but it won't, no, it doesn't move. Doesn't matter, not that exciting anyways. You can see me connecting to one of these cloud instances there, the client instance, and then you see that it's running Big Bug Bunny in full screen mode, so yeah. All right, then the server instance, where we load the asset from, is just a simple HTTP server. There's not too much fuss around that. And now you could ask, well, why do we spin up a separate cloud instance just for like one static asset? Why don't we load that from a CDN or somewhere? Doesn't that make more sense and things simpler? Well, partially, but that would be a problem for the results because we want to isolate these experiments. We want to reduce outside noise as much as possible so that the results are stable and that we get kind of deterministic results all the time. The default asset that's playing back that you would have seen earlier is our beloved Big Bug Bunny that we can see down here below. Now for the network shaping part between the client and the server, if you're wondering how you would define that, it's just an array of JSON objects in a configuration file. We have 3 sections in these JSON objects that are inside that array. First one being a duration that says how long does a certain bandwidth rule apply, here 10 seconds. Then we have restrictions for the server side. You can like specify the upload and download rate for the server and also the latency. Here we have 0. 0 means not no connection, but no restrictions in that case. And the third thing here is the exact same up and download limitations and latency, but just for the client, not for the server. So in here we have 372 kilobits per second, which is not a lot. And after that, after these 10 seconds, the next shape in the array comes into play. Again, 10 seconds, slightly higher download rate for the client. You don't have to specify these network shapes by your own. There is a preset of network shapes that you can use and set for these experiments. Listed them below. We have no limitations. We have stable network. We have fluctuation, which kind of simulates a fluctuating network. We have ramp up, which gradually increases the bandwidth, and ramp down, which gradually decreases the bandwidth over time. And what you can see here on the side is part of this ramp up profile. So every 10 seconds, we would increase the bandwidth step by step until we arrive at the reasonable download rate for the client. If you're wondering how is the connection now between actual bandwidth shaping and this configuration file, there's a script that reads what's in this JSON array and applies it via the TC command. TC, maybe some of you have used it already. It's a pretty low-level Linux command, which is a bit cumbersome to use, but very, very fast because it's that low level and you don't have any delays when switching between network shapes that way. All right, so now that we have our playback session conducted, our client reported all the data back, our server reported all the data back, it's time to calculate a result. And we need a lot of input there. On the blue side, we need first a display resolution that was used for the playback, a device type, because quality of experience varies whether it's mobile or a stationary device. That's a difference. We need all of the stall events. Where did they occur? How long did they last? We need video information for every segment, like codec, quality, frame rate, and something similar for audio. Now, there are different modes in this algorithm that I showed you earlier. And depending on how much data you stuff into it, the more accurate the result is going to be. So you could even provide stuff like quantization parameters per frame, or you could provide the whole video bit stream and the result will be even more accurate. However, that also increases the computational complexity a lot to calculate the result, so use it with care. In exchange for providing all of this data, we get some results for our playback session. First one, a mean opinion score approximation. Why approximation? Because mean opinion score technically is only what you get from a human, their opinion, right? And everything that's produced by an algorithm is just an approximation of that. We also get the startup time, which is this initial delay factor that I showed in the quality of experience slide, the overall store duration and the overall media duration, like how many seconds of content have actually been played in that playback session. So CadVise is a research project. Bitmovin is a company. Where is the link between that right now? The current state is that we have investigated heavily in the last couple of months how we could use that and found some pretty cool use cases for it. First and foremost, the obvious choice, benchmarking ABR changes. So if you have a player, you have an ABR, and you're doing changes to it, you want to know if they are impacting the quality of experience positively or negatively. So that's now not a shot in the dark anymore, but something that you can measure. You can even go as far as securing your software releases, your player releases with that, putting on top of your regular unit, system, and integration tests these ABR tests and say, well, if we deteriorate strongly in comparison to the last release, we're not going to release. And otherwise, you wouldn't know. And you can, of course, set up some reporting around it, like checking out how did our ABR evolve over time? Did it decrease slowly ever since? Or are we stable? Did we even get better? So lots of data munching and crumbling that you can do there. We also employed some extensions. So as you saw, the script is a bit cumbersome to use because it has lots of dependencies. And if a developer wants to schedule an ABR experiment, that's not exactly effortless, but takes a lot of effort to set up the workstation. So we wrapped all of that into a web service. So the web service does all of the dependency handling and all of the setup. What you need to do is just issue a post request to that web service, specify the parameters that we previously saw in the script, now in the post request, and you can easily schedule ABI experiments as long as you can issue a post request. We also allowed for specifying player versions. Previously that was static and you would have needed to update that. That's also now possible in a field here. And we added some capabilities for low latency streaming, which also wasn't present in the initial version of CadVise. So now back to our initial problem. If you remember, on the third slide, I think, I showed you these two ABRs. The first one that always chooses the lowest quality, and the second one that always chooses the highest quality. Now, to compare it, we just issue 2 post requests to our newly found service, let it run, let it calculate, let it do its thing, and find out what the result is. So I actually did that and got some data out of there. Here you can see on the x-axis the different network scenarios that were used for the tests, and on the y-axis you can see the mean opinion score from 1 to 5. Again, 5 is good, 1 is bad. The blue one is the high quality ABR that always chooses the highest playback quality. Orange is the low quality ABR that always chooses the lowest playback quality. Now for the network 0 profile, which means 0 restrictions in terms of bandwidth, the high quality ABR is performing really, really well, which is just what we would have expected, right? Internet in the AWS data centers probably is pretty fast, and we're not placing any restrictions there. We're choosing the highest quality from the beginning, which is not an issue because we have so much bandwidth, and then we have a great quality of experience score, or MOS score, of 4.4. That's close to perfect and just what we would have expected. On the other hand, the orange one, the low quality ABR, just has a score of 2.05. Even though we have such great bandwidth conditions, we always choose the lowest quality, right? No matter what. So for this specific scenario, the low quality ABR probably isn't going to make it. For the stable profile, it's a draw between the two. Blue and orange both scored 2.1 in that case, because we're probably having some stalls already. I think the stable profile plays back at 3.8 Mbit, and the highest quality for that stream was full HD. So you are kind of close with the buffer depleting all the time. So lots of stalls cuts the quality of experience into half for that specific profile. Similar picture for fluctuation, network like increases, decreases all the time. For the times where we have good bandwidth conditions, we play back. For the ones where we have bad bandwidth conditions, we are starting to deplete and stall, which is why the high quality ABR also doesn't perform well. Finally, in the ramp-up profile, even the low quality ABR is better. And if you think about these 3 factors that I showed you in the beginning, initial delay was a concern. How long does it take from the playback start until the playback actually starts? And the ramp-up profile means we are starting with low bandwidth and increase it over time. The high quality ABR doesn't care. It chooses the highest quality even though the bandwidth is super low, so it takes super long for the buffer to fill and to start playback actually. And we are having the worst MOS score in the whole chart here with 1.6, and our low quality ABR is at its stable 2, like everywhere. For the ramp down profile, this initial delay is not as big as a concern because the high quality ABR chooses the highest quality, we have a lot of bandwidth, and just in the end it's starting to deplete the buffer and starts to stall. You can also beautifully see that here. And the orange one is again at the 2, like everywhere. All right. Some sources and links. I dropped lots of numbers and lots of repositories. So in case you're curious about anything of that, basically, here are your sources and here are your links. And also big thanks to the amazing artists that made this presentation a lot more colorful than it would have been otherwise. With that, thank you for your attention. I hope there was a bit of information for you that was interesting, and I guess the round is open for questions.
Thank you. So I've done a really rudimentary version of some player testing that was like vaguely similar. And I'm curious, is the primary browser, the only browser you're using there is Chrome?
Yes, for this, the way it's implemented, yes, it's only using Chrome, but it's easy to exchange that. So there is Selenium for the browser automation, but you can launch any browser because the reporting is done in the HTML page that you launch. So the HTML page sets up event listeners and stuff and reports back to the log database, and it doesn't really matter on which browser you open that. So you could really use any browser as long as it's installable on the cloud instance that you're using.
Got it. Okay, so that, yeah, my question was going to be there, like, is being able to use other browsers why you wouldn't just want to use like the Chrome network profiles or anything like that?
Chrome network profiles actually don't allow you to shape server bandwidth restrictions, right? So we had this server restriction part where we could also change latency and stuff for the server, and that wouldn't have been possible. Only client-side stuff is possible there.
Yeah, one question here. Do you plan on integrating also the quality of the asset into the equation at some point? Because your bitrate ladder impacts quite a lot on the results.
Yeah, that's a big factor for the quality of experience. The fun thing is that the higher you go in the modes of that algorithm that I showed you, the more detail you need about the stream itself. So you saw you provide in the higher modes quantization parameters and stuff like that already. So that kind of judges your asset quality already, and not just the stalls and stuff. So on the lowest mode that we're using, where you just have stalls, quality switches, and some metadata, you only account for network conditions and quality chosen. But on the higher modes, which you could activate, you're free to do that. If you provide the data, you can already judge asset quality as well.
Thanks. And one other question. Does it support Dash HLS, or it doesn't care?
It doesn't care,
okay.
Because the event listeners that report back are set on the player. If the player can play back Dash and HLS, you just feed it back into the database.
Okay, thanks.
Okay, hi.
Hey.
So thank you for the presentation. I knew this CadVise, so we tried to use it a little time ago, and I was wondering, because you just said it works also with HLS, but you didn't put HLS.js. Is it still...
You mean why HLS.js isn't in the standardly supported? I'm not sure if there is a justification for that in the paper. I think you could just integrate it as long as you set up the event listeners there. Maybe the players that were used were known by the author, and HLS.js just wasn't in the scope of doing that. But there's nothing preventing you basically from also using HLS.js.
Okay, so the Bitmovin one can work in HLS or Dash, right?
Yeah, both.
Okay, so we can try it with this one, right?
Good idea.
And you mentioned the low latency. So is it only, is it available for everyone, or is it you made it only at Bitmovin?
We internally have been doing that just recently. There are some challenges there, like you can't just set up static content, right? You need to create a live stream. And also, like, there need to be some changes to the ABR because you're loading the segment from the bleeding edge and don't get the actual network quality. So these changes were internally. They are not in the original version of CadVise, but there is a separate paper that has been released 4 months ago, I think, about low latency CadVise. You can look that up. There's even a repository, I think, and an open source implementation.
Okay, thank you. Just one short final question, because at the end you mentioned for all the results you got for all the different references, and I want to know if you got some recommendation in that case related to the first segments. So at the beginning of the session, we don't know at all what's gonna be there. So you said it's 16 seconds max, and then it is bad. But would you have some kind of recommendation in that case, what to use first? Would it be the lowest one or the highest one?
That's a very tricky question. So how optimistic are you regarding your user's internet connection is the question there. So that's actually a concern. So you maybe could accommodate for that. You could also be very pessimistic and choose the lowest quality all the time. Or you could start the download in parallel, for example, measure that bandwidth and use it for estimating. There are lots and lots of different approaches and even lots and lots of papers around that. And there is no one thing fits it all approach. You need to be a bit selective there and take multiple factors into account.
Okay, thank you.
Welcome.
Thank you for the talk. I've got a quite similar question than the previous one. We were talking before about Wi-Fi train and fluctuating network conditions. Do you, at Bitmovin in particular, take that into account? I mean, do you try to keep some kind of leeway, some extra bandwidth just in case it will go down, and like not select the highest possible bitrate that you could get away with, just in case?
Just in case it drops, you mean, and then you're suddenly not able to play back anymore. Yeah, that's actually also a big research topic, the stability of ABRs, because as you say, they can fluctuate, or you can even compete with other clients in the network regarding the available bandwidth, right? So you can never be really sure that you have that bandwidth for granted and need to accommodate for that. There are mathematical models that accommodate for that, like how long have you played back a certain quality in a certain stability point, and if you are like having played that back long enough, you're confident that you can switch up if you have available bandwidth. Same goes for switching down. So if you're already like playing on the edge and you see that your buffer depletes pretty fastly, it's a good idea to start stepping down gradually, in the best case as we saw, so that you are not running out of buffer. Yeah. So smart ABRs do accommodate for that. Even if there is no network for short periods of time, you're able to compensate that.
Okay, thanks. And I've got one extra question. Would you mind going back to the results pages, please? Yes, this one. I'm a bit puzzled by the second column, the stable one.
Mm-hmm.
I don't quite understand how the orange could be 2.1, whereas the previous one, why is it higher? It should be.
You mean because it was 205 with no restrictions, and in the stable profile it's 2.1?
Yes.
I already thought that that question's gonna pop up. That's because it's not 100% deterministic, because there is so much stuff happening also, like in the data centers where you have your instances launched, and also in regards to the network, that all of this noise somehow can affect the results marginally. So you have a kind of a variance that you need to accommodate for. If you choose this network profile, it's not going to produce the same results in the same setup every time. Just because also you are, for example, loading your player via JavaScript as a JavaScript player somewhere, and that also takes different amounts of time, which then could affect how long this initial delay is and stuff like that. So you need to be aware that there can be small fluctuations in the results in both directions, yeah. But very, very detailed observer. Thanks for the question.
Thanks for the presentation. I would have a question about just here. I would have a question about your method to estimate the mean opinion score. Especially, have you studied how your estimation of the mean opinion score correlates with the actual mean opinion score that would be obtained with a standardized test?
Yeah. That's what these two papers, I think 7 and 8, quote or investigate, because there has been a competition going on who actually creates the best tool for estimating these mean opinion scores. And these two papers show how they first trained the model and how closely it correlates to actual subjective test database. Because there were subjective test data sets applied or offered for that competition, and here you can see that it correlates. I don't know what the actual percentage is or how close these estimations are, but yeah, that was basically the best out of all of these implementations in the competition.
Thanks.
Thanks for your question.
Hi.
Here.
Yes, it was pretty much the same question. It was more, is it possible to adapt the calculation of the mean opinion score to your domain and to your specificities? Because as you said in the beginning, if you are playing short contents or specific contents, you may want to have a lower startup time or things like that. Is it possible to just configure the calculation?
I think you can't simply configure it. However, you can tweak the script that does the whole calculation, because that's this reference. It's like this repo, in case you're wondering then. is open source as well, or at least openly accessible. And you can, if you know what you want to achieve, you can just tweak that, fork it, and use that for your estimations. So
Okay.
yeah, there's a possibility, just not a very easy one.
Okay.
Hi, quick question. Did you learn anything surprising since you've been using this pretty heavily, or was it just kind of confirming that what you were doing before made sense?
I would say there were no huge surprises, because over time, like, our player has been out in the wild for a long time now, right? And previously, when we weren't able to measure anything, the customer will tell you if your ABR is great or not, or if there are issues in certain scenarios. However, it adds some confidence when releasing new ABR versions. So no big surprises here, but I guess if you're developing something new or pretty fresh, then there could be something that's surprising for you.
Okay, thank you for the talk. Thank you for your questions. So let's move to the last talk, and Matt will talk about service worker.
We lost it again. My bespoke artisanal slides. And how do I get to the browsers when I get to that part? Right there. I also organize a video tech meetup, and I will say it's very nice being on the other side of this experience right now. Okay, well, the opening slide is just like my name and stuff anyway, so I can at least do that while we get this up there. Somebody point when it actually shows up. You got me there, right? So hi, my name is Matt McClure. I'm going to be really annoying and make y'all, raise your hands and stuff a little bit at the beginning. But I started a company called Mux, which you'll see on a slide. But before that, I started a conference called Demuxed. And before that, I started a meetup called SF Video, which I was very proudly talking about how it was like one of the first video meetups. And I think it was Simon that was like, we've had that since like the 18th century or something here in Paris, but whatever. So maybe not the first, but an early one. So yeah, real quick, I was very glad, Andy, thank you for the excellent talk. I was very glad to see some JavaScript and client-side player stuff up there, so this won't come out of totally left field. Who all here, well, I'm gonna start with the Demuxed. Who all here has like been to Demuxed or heard of Demuxed? Okay, cool. It's a conference for video nerds, much like everybody in this room. It's in San Francisco next month. This is our 9th year, so next year's our 10th year. You should come this year, but you should also come next year because we're gonna try to do it big. Who all here has like ever works in players or browser technology or anything like that, like on the video side of things? Okay, so slightly less. Done any sort of media manipulation whatsoever? Like mess with, hell yeah, okay. Okay, cool, so we got through most of this. I'm Matt. So we're gonna be talking about service workers. Who all here has heard of service workers? That's the last question I'll ask for a second. Okay, like I feel like more people raise their hands for who's heard of service workers than who's working with browsers, but there's a lot, we'll get past the fibbing here in a second. Okay, so for those of you that didn't raise your hands on the what are service workers side of things, service workers they're stable, they're well supported. still feel pretty new. Like if you still think ES5 is a normal thing, or ES6 is a new thing, you definitely think service workers is a new thing. So service workers are JavaScript that you can install in your browser that you can then use to intercept requests and do other things. So this is, for example, at the very bottom of the screen, you'll see some this is the most common piece of code that you'll see in something like this. Like whenever the fetch event happens, I want to add this listener that will then, I don't know, cache stuff or something. And if this thing exists in the cache already, or I'm already offline, respond with that thing out of the cache. So really common. It runs in its own thread. It runs completely separate from the client-side JavaScript. That's that. So the most common use case for this is, as I said, caching. So if you're building like a progressive web app or something like that, and you want your progressive web app to be able to work when you go offline, so if somebody's going through a tunnel or whatever, you still want your app to be able to function. Your service worker would be smart around going and caching those requests, and the app itself, your client-side JavaScript, would still think it was online, or it wouldn't matter because it would still be getting responses back. But what a service worker is doing in all of that is intercepting HTTP requests, making their own requests, and then manipulating the responses coming back through, which is pretty cool. So if it can be a proxy, media proxy, it will be a media proxy. I think someone probably said something like that. So really simple use case for this. And also I probably should have started with this. This was like more of a lightning talk situation because this is definitely more of a hack than it is something I necessarily think anybody should do, but it's fun. So let's think through some of the opportunities. So really simple example would be limiting resolutions. So the workflow here would be you intercept that multivariant playlist request, your JavaScript on the service worker side of things just removes some lines from that string of HLS, of the manifest, and then you return that modified playlist back to the client. This might sound silly, but this is actually a pretty reasonable thing. So for example, you might want to add a bitrate selector to your to a native iOS player, not native iOS, but like in Safari or something like that. You cannot do that. Well, I guess now in iOS 17, maybe they're blowing up my spot a little bit here by having service or media source extensions there, but you would not be able to do this there, except you could. In this case, you could say, okay, if you could have the client be able to say that, have the service worker only choose whatever their selection is, and then that's all that the native implementation would get. Or you could say, if I'm, this player right now is only playing back screencasts, for example, in which case, like, you never want to go below like 720p because then the text is unreadable anyway, so you strip out everything below 720p and send everything else. So gotchas here in the service worker world. The trailing slash, really important. If you're using Vercel or something like that, and it's getting cute and removing your trailing slash, you're gonna have a bad time. The deal with service workers is because of security implications, you always have to be, like, when you install a service worker, you're saying, if I install it at like /foo, it can access everything under /foo. So /foo without a trailing slash, it would not register. Anything under that child, it would. CORS still applies if you're doing this kind of stuff, or you're manipulating these requests and you don't respond with CORS headers, you're gonna have a bad time. Keep in mind, your client-side code does not know about the service worker, so you have to treat it like it's an external server. And the first requests after initializing are not gonna happen. So like, initialize your service worker before you're going to get to a page or implementation where somebody would want to use it. Okay, so less simple, a little bit more fun is, say, client-side stitching. So you want to build like say you have an application where somebody could select a few different videos or whatever else. You want to play that back like a one continuous stream. You want it to feel like one stream, but you want it to actually be multiple videos. So you could fake a URL. You could just say like https:// whatever your playlist ID 1, playlist ID 2, playlist ID 3. You go fetch the playlist for each of these, and then you slap them together with discontinuities, and then you return that to the client. We'll get into an example that actually makes a little bit more sense there. But the bonus here is that fake URL. Okay, so what's happening here is that the service worker is saying, like, whenever I see on that fetch event that we were talking about back here, whenever I see that event listener and the URL matches this stuff, so it could be this fake URL, don't actually request fake URL. Instead, request the URLs that I know exist for that ID, go fetch all of those, put them together, and then respond. So that fake URL doesn't even exist. You could use example.com and it would still work. But what gets cool there is you can actually have that fake URL be real. And as long as you're deploying to somewhere that supports the fetch event, you would be fetch compatible. Like, as long as you're deploying to a fetch compatible edge, Cloudflare, something like that, this would continue to work. So the fun thing there is you could actually, you know, if you're, again, I'm not saying this is necessarily a good idea, but if you're very like cost conscious, or you're saying to your users, you could deploy this proxy somewhere, it would work. But generally speaking, it will run in the client because these things are really well supported across browsers. But if for some reason somebody shares a URL somewhere else outside of a browser you control, it will still actually work. Kind of a neat little feature. So how this actually ends up looking in the wild. So this, for example, I actually was like doing this on my own laptop, so I have no idea how this is going to work showing it. But this is an example of just a filter resolution. So if you're actually looking here at these requests, so this one, I hope I can, how can I, no, I want to see more of it. Oh boy. There we go. It's mostly just the whole fact we have like a left and a right click thing. That's confusing. Okay, so this response is what the actual browser client saw. So this is, you'll see, I really hope this is at least somewhat readable, but oh boy. Somewhat better? Okay, so yeah, you can see 720 is kind of your smallest rendition there. Over here, if you look at what the service, not now, Siri. If you look at what the service worker actually sees, you'll see a much larger bitrate ladder. Kind of cool. The HLS demo side of things, so like, I was going to show like, oh, here's what it looks like in the client. Here's what it looks like when you actually just shove this thing in a Cloudflare worker or whatever. But this is just on the worker's dev service worker that says like, okay, I'm using Mux playback IDs here, but it could be anything. If you had like a manifest file name or something like that in S3, as long as you have a common root. So it's playback ID 1, and then I'm just copying it. So / playback ID, that one again. And then, is this audio gonna work? We'll see. Nope, audio's not working. Okay, well, what's happening here is this is my like moment of glory where they mentioned SF Videotech, and take that, Paris. The one claim to fame we have is that we were on HBO one time. Vaguely, kind of. So yeah, you'll see this clip is actually like 8 seconds long, but it's 19 seconds long. Let's see if we take it up here. Well, whatever, I don't need to show. Y'all get the gist. If we keep slapping that playback ID back at the end of this thing, it would increase by 8 seconds every time. Wow, that's amazing. So yeah, that's kind of it. Service workers, you can proxy media right in the browser. You can also deploy that stuff to the edge in the same way. It's like isomorphic media proxies, which is kind of fun. I don't know if this is a good idea or not to actually try, but it's a fun hack. And that's that. I'm Matt. I work at a company called Mux. You should come to Mux next month. That's it.
Do you have some questions?
So did you see some actual companies out there thinking this was a good idea to use that? Okay, Bitmovin is using it apparently.
So we ran into the problem a few years ago that the Safari HLS playback with ISO-based media, when they switched to e-message tags in the ISO-based media, I mean, part of the HLS spec, but not supported in the HLS native playback of Safari. So how the heck do you get the e-message box out of the segment? So you can use a service worker in the browser for that to pass the segment and get the e-message out of it. So that's one use case that we had. A little bit of a hack.
Boom.
No need for you, Matt.
But no, we actually have seen some customers use this in the wild. mostly around light things, like again, like the companies that were building screencasts. Like that was an actual example. Folks that were doing screencasts, they didn't want their customers never, like it wasn't useful for them to get less than 720p. They also didn't want to run their own proxy. They just wanted to be in the client. So this was a way around it for them just to be able to like lightly say like, okay, actually only send 720 and above. It was, I don't know if it's the best solution, but it was a solution for them and they're happy with it. So.
It's not a question, but I love it. I love it.
Oh, okay, there we go. Thank you.
It's stupid, but I love it.
Was it for the Demux talk selection this year? One of the comments on one of the talks that got accepted was, actually it was Derek that commented this. You didn't hear me say that, but it was, this is disgusting. I love it. Here's it is.
Okay,
thanks everybody.
Okay, so thank you for all the presentation. Now it's time to move and to go to the bar. If I can come back to my presentation. Yeah, here it is. So we can continue the discussion at the bar Les Marquises, so you can follow us. And yeah, this is the end for tonight, at least for the presentation part. So thanks a lot, and see you at the bar.